How will robotics improve space research over the next 50 years?
Let's talk about that. The new discovery of robotics is a game changer when it comes to scientific research.
It is quite helpful and is quickly hastening the process of space exploration. One example would be how the discovery of soft robotics is providing support on both the astronaut side as well as recreating the surfaces of planets that we'd like to inherit. This allows them to use the system to make the lunar and Mars surface to help further the development of habitation there.
A soft robot is a mechanical system that is flexible and compliant and is not a standard hard or rigid system. On Earth, people don't work alongside robots because it's dangerous. However, soft systems are far more compliant, so when they hit someone, there's a lot less chance of getting injured or killed from the contact.
Currently, for an experiment, they are creating silicone and pouring it into 3D printed molds, which they will then fill with the silicone. They will then allow the silicone to harden and wire the system up, afterwards conducting their tests. First, they look at leveling, then shaping, joining, and locomotion. They also use soft robotics to give astronauts more power to lift, walk, run, and ease the workload for a longer time in space.
An ambitious robotic revolution will foster creativity and innovation, advance needed technologies, and transform the relationship between humans and robots. Key areas of this research that will improve with better robotics includes
mobile robotic systems. Advanced robotic systems that combine mobility, manipulation and sampling, machine perception, path planning, controls, and a command interface to be capable of meeting the challenges of planetary exploration.
In manipulation and sampling, extending our manipulation and sampling capabilities beyond typical placement and simple acquisition, such as those demonstrated with the Mars rovers, could make even more ambitious robotics missions possible, and with that, the amount of information we can receive is larger.
Or machine perception and computer vision. Our ability to control robot functions remotely is severely constrained by communication latency and bandwidth limitations. Autonomous mobile robots in the next decade might be capable of perceiving their environment and planning the maneuvers to meet their objectives. Future missions will definitely benefit from the development of robotic systems with advanced machine perception and computer vision technology.
Lastly, path planning. Advanced robots need to be capable of traversing the Martian terrain, flying through the atmosphere, floating on Titan's legs, and diving into Eurepa's oceans. They are also developing path planning technologies that will improve greatly with more robotics research for robotics vehicles operating in a variety of planetary environments.
Another area of interest is user interface. Graphical user interfaces, GUIs, and scripts currently used to create robot command sequences for operating rovers on Mars could be insufficient for future robotic missions, in which we would need to interface with multiple robots in complex situations, including interactions with astronauts. At a minimum, we need to, and will, develop a more efficient way of commanding robots.
Overall, space research in the next 50 years will improve greatly with advancements in robotics.
Nothing about this future is guaranteed, but robotics could also address one of the biggest problems in space exploration: expenses.
In conclusion, if we continue in robotics research throughout the next 50 years, it could help us very much in exploring and inhabiting other areas of our solar system.